Hello and welcome. In this video tutorial, we are going to work on the acceleration due to gravity. Please remember to pause or rewind this video as needed. Now, this tutorial goes along with Skills Practice 2.3. Let's begin. Recall that the acceleration due to gravity is the acceleration caused by the force of gravity, and it is essentially a constant acceleration concept, but directed in a vertical, that means up and down direction. So you might remember that we had in the horizontal direction, we had equations that look like v equals v naught plus at, x equals v naught t plus 1/2 at squared. This, if you remember, was equation 2. This was equation 3. Equation 4 was v squared equals v naught squared plus 2 times a times x. And equation 5 was x equals v plus v naught over 2 times t. Now, when we're talking about free fall acceleration, that's in the vertical direction, we end up doing the following. We translate all of the a's into g's. So the first equation, number 2, becomes v equals v naught plus gt. We also translate x into y. So equation 3 becomes y equals v naught t plus 1/2 gt squared. Equation number 4 becomes v squared equals v naught squared plus 2 times gy instead of ax. And equation number 5 becomes y equals v plus v naught over 2 times t. The same premise holds for constant acceleration. We're going to list a series of 5 variables, and based on the variables that we have listed, we're going to choose the right equation. Let's take a look. Now, for the organization of our problems, number 1 is going to be the first problem-solving box. Number 2, number 3, number 4, 5, 6, and on the last page, 7, 8, and 9. Now, take a second to go ahead and cross out number 6 and number 7, as we will not be doing those in this tutorial. Question 1. A penny is dropped from a wishing well and reaches the bottom in 1.5 seconds. What was the velocity at impact? Well, since you have a penny falling, this is an example of free fall acceleration. If the penny is dropped, we know the initial velocity is equal to 0. 1.5 seconds would be the time t, and we're looking for v, the final velocity. Let's organize this in our problem-solving box. We are looking for v. The other variables would be y, v naught, g, and t. Now, we don't know how far the penny fell. We do know it fell from rest, y naught equals 0, v naught equals 0. We know that the g, the acceleration due to gravity, is negative 9.8 meters per second squared. And we do know it fell for 1.5 seconds. Now, This is my speed that I'm looking for. I've got v naught, g, and t. This is going to correspond to equation number 2, which has v naught, g, and t. So we can start by writing down the main equation, v equals v naught plus at, and then our solutions box, we're just going to translate it to v equals v naught plus gt. Now, since v naught is equal to 0, we can go ahead and cancel that part of the equation. And this becomes v equals g times t, which is equal to negative 9.8 times 1.5. Since the question asked for velocity, we should be including a negative in our answer. Pause the video and go ahead and put this in your calculator. You should have come out with about 14.7 meters per second. The answer is negative because we have the negative 9.8. Now, one way to represent that answer is with negative 14.7. You could round it up to negative 15, that'd be fine too. But having the negative there is one way to represent our answer, because velocity needs a direction. Or we could say 14.7 meters per second and then just simply write the word downward, and that would also suffice as far as the direction is concerned. So when we specifically see the word velocity, we have to include a direction along with the speed. Let's take a look at number 2. A pitcher threw a baseball straight up at 35.8 meters per second. What was the ball's velocity after 2.5 seconds? And it's telling us the ball's climbing, gravity is accelerating it downward. So this is another example of free fall acceleration. The pitcher threw the ball with that initial velocity, so that would be v naught. We want to know the ball's velocity after 2.5 seconds. So again, we're looking for velocity. We do not know how high the ball got. We do know the speed, g and t. The speed we were given is that the pitcher threw the ball at 35.8 meters per second going upward. G is always negative 9.8. And the time in this question was 2.5 seconds. Again, I'm looking for a formula that has v naught, g, and t. That would be equation number 2. Translating it again for free fall acceleration, a becomes a g. I cannot cancel anything this time, so I simply plug in 35.8 plus, and then negative 9.8 times 2.5. We have to remember to take care of the multiplying first. So if we multiply those first, we get 35.8 minus 24.5. Then when we subtract those two, we will get 11.3 meters per second. Since the answer is positive, the velocity is upward. Number 3. In a bizarre but harmless accident, Superman fell from the top of the Eiffel Tower. How fast was Superman traveling when he hit the ground 7.8 seconds after falling? Well, Superman falling to the ground would again be an example of free fall acceleration because gravity is accelerating him. Since he fell, we're going to interpret that as v naught equals 0 because he wasn't thrown down nor was he thrown up. He dropped. He jumped. We're looking for how fast, so we're looking for V after 7.8 seconds. Let's organize our information. We're looking for how fast. We do not know the height of the Eiffel Tower. V naught was 0. G was negative 9.8 again. And this time T was 7.80 seconds. Pause the video and try and figure out which equation would help you find V given V naught, G, and T. You should have selected equation number 2, V equals V naught plus AT, and translating it for free fall acceleration, A becomes G. I can cancel V naught because V naught is equal to 0. Negative 9.8 times 7.8. Go ahead and pause the video and run that calculation. Well, if you did it correctly, you should get about negative 77 meters per second, negative 76 point something, but about negative 77 meters per second. Now, since the question is only asking you how fast, all we care about is the speed or the number part. So 77 meters per second is how fast he's falling. If the question specifically asked for Superman's velocity, you would include the negative. Since it did not, we just include the speed or how fast he traveled when he hit. Number 4. Read along with me, please. A water balloon was dropped from a high window and struck its target 1.1 seconds later. If the balloon left the person's hand at negative 5 meters per second, what is the velocity on impact? Well, I think this word dropped is a poor word choice because really the balloon was thrown down. Specifically, it was thrown down with that velocity, so that would be V naught. 1.1 seconds later would be time, and we're looking for velocity. You can tell this is free fall acceleration because even after the water balloon is thrown down, gravity will continue to accelerate it downwards. Well, again, we're looking for V. We do not know the height from which the water balloon was dropped. We do know the initial velocity was negative 5. We do know G is negative 9.8. And we do know T was 1.1 seconds. Again, you can see we're going to be using equation number 2. Which translated gives you V equals V naught plus GT. I cannot cancel anything because nothing is 0, but I've got negative 5 plus negative 9.8 and 1.1. Negative 5.0. Take the time to multiply that part first, and that's negative plus a negative 10.78. And when we add those together, we get negative 15.78 meters per second. Since the question asked for velocity, that would be a sufficient answer, including the negative in your answer. Of course, the other way to represent the answer would be writing the speed, 15.8 meters per second, with a direction of downward, because the negative indicates that downward direction. Number 5. A stone tumbles into a mine shaft and strikes the bottom after falling for 4.2 seconds. How deep is the mine shaft? Well, tumbles, kind of a synonym for dropped. Since the stone is falling, it's falling, gravity will accelerate it. Again, this is a free fall acceleration concept. V naught is 0. Tumbles implies that it's dropping from rest. 4.2 seconds is time. This time we're looking for how deep. How deep would be y. Let's label our information for number 5. We're looking for how deep. We do not know how fast it's going when it hits. We do know that it starts from rest and that g is negative 9.8 and that t is 4.2 seconds. Pause the video and try and find an equation that matches y, v naught, g, and t. Well, if you remember, x and y represent the same thing. So the equation that matches that list would be x equals v naught times t plus 1/2 times a times t squared. Translating this to vertical free fall acceleration, x becomes y, v naught t is the same, plus 1/2 g t squared. Now, if you remember, v naught is 0, so 0 times time is all 0, and that middle term completely goes away, reducing the equation to y equals 1/2 gt squared. When you plug into it, we have y equals 1/2 times negative 9.8 times 4.2 squared. Now, to run this calculation correctly, we need to go 4.2, square it, times negative 9.8, then divided by 2. Pause the video and run that calculation in your calculator and see what you can get. If you put it in there correctly, you should get negative, you see there's a negative right there, negative 86.4 meters. Now, since the question is asking how deep, we're looking for just a distance or a height, if you will. Height and depth kind of mean the same thing. The question did not ask for displacement. If the question asked for the stone's displacement, we would have to use the word negative or negative in the answer or the word downward. But since it just asked for how deep, that is just a measure of height, depth, distance, and the answer would just be 86.4 meters deep. Remember, ladies and gentlemen, we skipped 7 and 6. Let's take a look at number 8. Number 8. Read along with me, please. At about 55 meters per second, a falling parachuter, before the parachute opens, no longer accelerates. Air friction opposes acceleration. Although the effect of air friction begins gradually, imagine the parachuter is free falling until terminal speed, the constant falling speed, is reached. How long would that take? Well, this is kind of a confusingly worded question. You see, this particular speed here, that is the terminal velocity in the problem. If you were to convert that to miles per hour, that's approximately 120 miles per hour. So what that means is gravity will accelerate a person jumping out of an airplane until that person reaches about 120 miles per hour or 55 meters per second. At that point, the person will continue falling at that constant rate of 55 meters per second, the remaining part of the fall, until the parachute opens. Once the parachute opens, the person will essentially change to a different terminal velocity because a parachute has a much greater surface area and interacts with the air resistance at a much greater level. So that's the terminal velocity. Terminal means end, so that would actually be final velocity v. One assumption we have to make in this question is that when a parachuter jumps out of a plane, they simply just drop, and their initial speed would be 0 out of the airplane. They simply just fall. We want to find time it takes to do that. So let's take a look at how we would organize this. We're looking for t. We do not know the height that we're dropping from. We do know the initial velocity is 0, and we do know the final velocity is 55. What we need to be careful of is, since we're talking about a final velocity, the final velocity is actually negative 55. Remember, the parachuter is going in downward direction. And then finally, of course, g is equal to negative 9.8 meters per second squared. We can use the equation for t, v naught, v, and g as, again, equation number 2. Rewriting it, of course, it's v naught plus gt. Canceling the v naught because the sky jumper starts from rest, we have v is equal to g times t. But this time we're solving for t. So we have to remember to divide away the g. And time is equal to v divided by g, which is negative 55 meters per second over negative 9.8 meters per second squared. Notice how important it is to have a negative velocity here, because negative divided by negative gives you a positive time. Had you forgotten to put the negative velocity in there, you would end up with a negative time answer, and time can never be negative. Take a second to put that in your calculator and calculate the time it takes for a skydiver to reach terminal velocity. You should have gotten somewhere around 5.6 seconds. Lastly, number 9. A climber dropped her compass at the end of her 240-meter climb. How long did it take to strike the bottom? Well, dropping the compass, again, free fall acceleration all across this board here, because all of these examples are objects that are either climbing but slowing down because gravity acts on it, or dropping and speeding up because, again, gravity is acting on it. So anytime gravity is accelerating the issue, accelerating the object flying up or down, then that's a free fall acceleration problem. Dropping the compass indicates that v naught of the compass would be 0. 240 meters would be y, that's the distance that it fell, and we're looking for time. So looking for time, we know that it fell a distance of negative 240 meters. We have to include the negative in there because that's the distance the compass fell. It fell 240 meters below the point at which she climbed to. We know that we do not know v. We do not know the speed at which it fell at. We do know that it dropped from rest. And we do know g, right, is negative 9.8 meters per second squared. So looking for a formula that has t, y, v naught, and g, go ahead and pause the video and select the correct equation. If you selected correctly, you should have selected equation number 3, x equals v naught t plus 1/2 times at squared. Translating it for free fall acceleration, x becomes y equals v naught t plus 1/2 g t squared. Again, 0 times time is 0, so the whole v naught t term cancels just as it did in a previous problem. But this time we're not plugging in to calculate y. We need to solve for t. So to get t by itself, you have to get rid of 1/2 the g and the squared. Let's take a look at this step by step. Y is equal to 1/2 g t squared. To get rid of the 1/2, we're going to begin by multiplying both sides by 2. you can see the 2 cancels the 1/2, and 1/2 is now gone. Rewriting this, we get 2y is equal to gt squared. Next step is to get rid of the g. Since g is being multiplied times t squared, we're going to go ahead and divide both sides by g and get t squared by itself. And so far we have 2y over g equals t squared. The last step is to get rid of the square. Well, the opposite of a square is a square root. So we're going to square root both sides, and now we're ready to plug in our numbers. And it's going to be 2 times negative 240 over negative 9.8. I hope you all now see why we had to put the negative here for the y, because if we put a positive 240 in there, we'd end up taking a negative square root, and our calculator would give us an error message. By having a negative displacement of that compass, the fact that it fell 240 meters or negative 240, we're able to cancel the negatives, and we can get a correct evaluation for time. Take a second to put that in your calculator. Pause the video while you do that. Okay, you should have gotten somewhere around the neighborhood of about 6.99 or roughly 7 seconds that it takes to fall. That concludes our video tutorial on acceleration due to gravity. I hope you found it helpful, and thank you.